Give me a minute. I'm able to share. It still shows that I'm disabled. That's right. Okay, let me get started. People have been waiting for more than 10 minutes. Okay, today we are talking about data engineering, and I'll jump straight into the topic.
Sir,
And
we have,
then,
excuse me, sir,
yep,
we have
yeah.
some address and
What is it?
introduction, sir.
Yeah,
We'd
yeah,
like
yeah,
to
please go
introduce
ahead.
yes, sir.
Yeah, please. Take your time. Yeah, please
Yes,
go
sir.
ahead.
Okay, sir.
Thank you, sir.
Yes, ma'am. Yes, ma'am. Kirtana, can you please share the screen?
Yeah, just a second.
Okay, fine. Before we will start the pre-conference talk, I would like to request all the panelists to switch on their videos.
Am I visible?
Yes, sir.
Okay,
Yes,
good.
sir.
Kitna?
Yes, Shivani, you can start.
Okay, ma'am. So it gives me an immense pleasure to extend a very warm welcome on behalf of the Jain University, who has clumped all of us for the pre-conference talk on preparation for the Industrial 5.0 Data Engineering. A warm welcome to Chilume 2022, Spring of Knowledge, the fifth edition of annual series of National Conference for the Faculty of Engineering and Technology, Jain deemed to be university. This conference is a platform for bringing together young scientists, leading academicians, building research scholars, and industrial professionals to share their research experiences as well as to exchange their ideas in the interdisciplinary domain. In addition to this, students will also learn a lot of social skills, and the webinar will include the debate and vote of the judges. With all those words, I'm extremely delighted to welcome our chief guest for the day, Mr. Vishwanath Kanagal, Project Director, Hexaware Technology, USA International Industrial Expert. I, Shivani Datta Motoyakar, would like to welcome our honorable chief guest and everyone gracing to be the part of this pre-conference talk. Hoping that this pre-conference talk can enlighten your preparation for the Industry 5.0 data engineering. I am thoroughly pleased to witness you all here in this webinar. It's my privilege to address you all. The world is full of diamonds and gems, and we are having some of them here today. To build this event with this note, I would like to give my heartily welcome to our speakers. Vishwanath Kanagal, Project Director, Hexaware Technology, US International Industrial Expert. And I also welcome Dr. Chendraj Roychan, Honorable Chancellor, Dr. N. Sundarajan, Honorable Pro-Chancellor, Dr. Raj Singh, Honorable Vice-Chancellor, Dr. Ishwaran Iyer, Honorable Pro-Chancellor, Ms. Ravindra Bandari, Vice President, Dr. N.V.H. Krishnanan, Registrar, Dr. S.A. Hariprasad, Director, Faculty of Engineering and Technology, Jain deemed to be University, Bangalore. And I also welcome to Jnana Chilume 2022 conveners, Dr. M.K. Jayanti Ma'am, Professor and MTech Program Head, Computer Science and Engineering, and Dr. Dushyant V. Babu, Associate Professor and HOD, Civil Engineering Department. And I further welcome all the departments, respected HODs, faculty members, students of Jain University, and dear participants from the various places. Now, I would like to request Hikmat Anisa to give a small introduction about the today's speaker.
A very pleasant good evening to one and all present here. It gives me immense pleasure for taking this opportunity of introducing our speaker for today's session, Mr. Vishwanath Kanagal, Project Director of Hexaware Technologies, USA, International Industrial Expert. He has completed his master's in computer applications from Mysore University in the year 1993. He is an IT transformation specialist with more than 25 years of expertise in his industry. He is specialized in large-scale IT transformation consulting, IT portfolio. He's an IT transformation specialist with more than 25 years of expertise in transformation consulting, IT portfolio, rational and digital evolution. He has played varied roles from solution architect, project and program management, transition and service delivery management, data governance manager to professional consulting practice management. Also, he has extensive experience of handling large-scale service delivery distributed across geographies and technologies. He is the project director in Hexaware Technologies since September 2014. He has led data management and project management teams along with client engagement and implementation at multiple clients. He has managed and implemented cloud migration and IT data transformation in a hybrid model at Fortune 100 companies. In addition, he has managed supplier diversity, data enrichment, and client engagement teams, achieving 10% YOY cost and resource optimization for projects in operational mode. He worked as the assistant director of EY from May 2010 to September 2014 before joining Hexaware Technologies. He had implemented global finance system for 240,000 employees across 160 plus countries, managed teams operating 24/7, serving 3 data centers with 3,000 plus servers and 100 plus terabytes of data residing on Oracle, SQL Server, NoSQL databases. His key skills are in data engineering, transition management, key accountant management, program management. We are fortunate to have such an eminent speaker to enrich us today with his knowledge. I welcome you, sir.
Thank you. That was very kind and generous. Right. Anything else from the organizer before we start?
That you can
Shivani,
start your session.
Okay,
there any-
thank you so much, Hikmatanisa, for introducing our speaker to us. Light is a symbol of brightness and prosperity. As sunlight expels the darkness of might, similarly blessing bring in our life prosperity and happiness. To make this evening a blessed one, invoke Goddess Saraswati by candling the lamp of knowledge and wisdom for seeking the choicest blessing for the same. I invite our dignitaries to virtually light the lamp before we start the session.
That's nice.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देवो सर्वकार्येषु सर्वदा. Thank you very much. While many manufacturers are still busy in developing methods for interconnecting new technologies to improve the efficiency and productivity, the guiding principle behind Industry 4.0, the next phase of industrialization, is already upon us. Industry 5.0 data engineering, much more than simply bumping up the industrialization one tick higher on the dial. It's the next step in the evolution of manufacturing. The term Industry 5.0 refers to people working alongside robots and smart machines. It's about the robots helping human work better and faster by leveraging advanced technologies like the Internet of Things and big data. It adds a personal human touch to the Industry 4.0 pillars of automation and efficiency. Before we start the session, I would like to kindly request all the participants to drop your questions in the chat box. You may send in your questions at any time during the presentation. We will collect this and address them during the question and answer session at the end of today's presentation. So I consider it is a great honor to welcome with a big applause Mr. Vishwanath Kanagal, Project Director, Hexaware Technology, US International Industrial Expert. to gain more knowledge and experience on today's topic, that is Industry 5.0. So,
Thank you. Right. Shall I go ahead and share the screen or?
yes, sir, yes, sir.
Yes.
All right.
You can share, sir.
Right. Thank you. I'm going to share the screen. Let me see if we can. Is it scrolling up or down? I just want to make sure that the screen is able to move. Can anyone say, are you able to see the screen?
Yes, sir.
Yes.
Yeah, visible. It's visible.
Great, thank you. Okay, so today I want to talk a little bit more on big data and primarily focusing on last two topics, which is primarily the data engineering part and the customer stories across the globe. Now, I want to start with a big anecdote on how big data does impact the world and the given situation that we are in now. Think about people are looking at various social media, and some of the industry giants like Google's, Amazon, they own most of the data transactions that are happening at any nook and corner of the world. And how do we monetize it? Monetizing the data is the biggest gain or boost, and that's the new oil that has been recoined for that is given to data. Think about it. When a person is looking at a Google ad, there is a revenue which gets generated for Google, right? A person sitting in Bangalore in Karnataka is going to look at the ad and they might subscribe, or they might even buy the services, or they might buy a product, or they might buy some goods. So indirect revenue has been generated for Google for facilitating this particular transaction. And think about all the social fabric, the network, the infrastructure that has been provided by government of Karnataka and people of Bangalore paying their taxes to keep the infrastructure up and running, but they are not getting anything in return. Now, if we churn this data well enough, and that is the biggest debate across the globe, where people are saying indirectly they are stealing the data. I'm hard to use the word, but the person who is looking at the ad, there is a screen time. Along with that, there is a person human time which was involved in this entire transaction. But the local governments or the statutory limitations which are being played upon by individual state or local governments, they are not getting anything written back in the revenue component, right? But the eyes have been made to look at the ad because they did not block any data that was being shared by either Google or Facebook or any of these companies, right? So there are two components to it. One is the access to the data and the transaction that was made by the person who looked at the data. So if individual governments, if they use this data well, then they can get a return, or they can share part of the revenue that has been generated by the citizens of that particular country or in the state that they are in. This is one such element that big data has changed the world that we look at, right? And a lot of benefits across, and at the same token, there is also another side or other angle to it, other flip side of the coin, where people can use this data for mining or to get what their narcissist needs. Okay. For example, I can take a data that has been shared by any state or any citizens that are living in any country. I can look at what ticks them emotionally.
Excuse me, sir.
And yeah.
Sorry, sir. Sorry for the interruption, sir. But sir, your voice is little bit low, sir.
Oh, okay. Let me. How about now? Is it better?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Okay. Good. Thank you. Thanks for that. Okay. And the same token I was talking about on the flip side to we were talking about the benefit, but at the same time, we can also use the data to influence the people or the citizens of any given country to vote for a particular political party. How is that possible? You can look at the data, what they're subscribing to, what kind of ads do they subscribe to, what kind of news media do they subscribe to, get the data, run the analytics on it, and then make sure that you are going to navigate your message for the preset set of citizens, and then you can get your votes. Okay, it's as simple as that. So you can use the data for any angle at this point in time, right? So big data has played a vital role across the globe for various countries to bring their organization or to keep the citizens either locked in or to write across whatever the agenda that they have kept. Okay. Now coming to the data engineering, I know all of this would result in how are we going to do the data analytics, and there is an AI component, there is a machine learning component for it, but all of them require the data. But how are we going to maintain the data? And that is the crux of today's talk about what is data engineering, right? We're not talking about social engineering. We're not talking about how do we get the outcome of the data that we have already assimilated or we have kept in any location. Okay. So now let us move on to, I'm going to ask a few questions. Let us make it interactive. So you would feel some of these questions might be relevant to you and how we started at some point in time, like 40, 50 years ago, and where we are today. Okay. Excuse me. Okay. We are also going to touch base on the challenges that today's business are facing when it comes to the data that they have to maintain and what is relevant and what is not. So there is a lot of noise. It is not just when we get a data, it is curated and it meets all your needs. Okay. Data could be scattered around and it can be more noise that you get in, but you need to make a sense of the data that you are receiving. And that's the whole topic about what data engineering is going to succeed in getting to you, right? Hopefully I'll be able to. Okay. Now, most of you know what industry or organization that you belong to. What is the total volume of data that individually you might be managing? I mean, you might be surprised at where would data get generated. You carry a mobile phone, there is a data about you, you have been profiled. You look at an ad, you have been profiled. You watch a news, you have been profiled. Nowadays, even because of smart TVs, you are getting profiled with what you watch and what makes you, it gets you up in date, right? And some of the topics that you are going to cover here, you may be able to learn more on how to get this data flowing, whether it is being streamed data or whether it's batch data. How are we going to get to the data different layers, right? There can be a layer where from the source, and how are you going to collect the data information from various sources, and how are you going to manage them? And that is the whole part of streaming and engineering, right? So nowadays, if you go to any bank, you will hear about, they talk about KYC. KYC is nothing but knowing your customer. How well they know the customer. what is the significance of knowing the customer, right? By knowing the customer, there is a security component, but along with that, there is a component of showing this customer what demographic do they belong to, and how can we sell some of our products to them, right? And knowing your customer makes it a lot better. It can be an individual, or it could be an organization, or it could be a government itself, right? Where you're going to use the data to sell some of your products. And how do you know your customer? So here is just a static data of about 4 or 5 elements, and it doesn't talk much about do I know this customer. No, it doesn't say much about the customer here. But if I am going to add some of the parameters to know this customer better, then this customer becomes a valuable asset for me, right? Every customer becomes a valuable asset only if and only if you know what data are they going to generate out of that, all right? These are some stats. You might have heard about this in different news media or wherever you're subscribing to. The most of the companies, right, whether it is Fortune 100 or Fortune 500 or even Fortune 1000 companies, they are talking about AI is their strategic priority going forward. And same question when it was asked few years ago, they were skeptical about it. The number is kept. Somebody is raising their hand. Okay. And now this is the total volume of data that gets transacted, and also there is a dollar amount to it. So as I mentioned earlier, we need to monetize the data. Keeping the data idle is kind of a dead asset, right? It becomes a liability. But if you churn the data, you make some sense out of it, then you are going to monetize the data. And this is the volume of data that people are talking about, close to $3.9 trillion. And this has been validated by Gartner, right? And this is the total business value that we are seeing that's going to be generated just in 2022. Think about it, by 2030, this amount could have exceeded GDP of India. Okay. So far, any questions? Am I going too fast? Let me know. If I'm going too fast, am I making some sense? Okay, I take it as now. Okay, so this is from PwC Global, which is PricewaterhouseCoopers. They're talking about how much of productivity that we can get out of our current data that we are generating in the global economy, right? Just look at China and India alone, what the economy that is being contributing to the entire world. So close to 9.9 trillion is the consumption side effects by the data that's been generated just out of 2 countries. Okay. And these are all like some of the factors that we are going to look at how the data is going to be impacting the rest of the world, which are being generated across in some nook and corner of the some Asian continent, right? Now, coming to the AI for the business, right? Primarily, we're looking at take the data, assimilate the data, and make some sense out of it. Why do we need AI at this point in time? AI is going to massive amount of data when it gets generated. Humanly, it's impossible to look at all the data parts and look at if there is any fraud has been committed, if there is any outlier that we have got on the data, or if the data streams that we are getting in is aligned to our business organizational motives, right? And knowing the customers, as we spoke before, who they are, what they do, and how are they going to use the product. And if there might be, like, we are selling hundreds of products, there might be only one product which is going to take, right? Or 1 or 2 products. Are we going to basically look at the rest of the products that we are selling, why they are not able to consume, right? And can we take the products which might be generated out of our organization, should we discontinue them, or should we need to do some more R&D? And that R&D, how we are going to do that, that's been once you know your customer, right? Once you know your customer, what their likes are, what their dislikes are, that particular data, once you have collected it, you can run through some of the AI components for it, run through some models, and you can generate the info that you're going to give to your product development department, right? And so once you have the customer database, once you know what products you are in, once you cross tally them, then you can improve your product, you can protect your business from the external snoop or malign, and also stay ahead of the competition. These are the objectives of for any business, right? For any business, their basic motive is to sell their product and to make sure that they are ahead of the competition based on the data that they are receiving from the industry, right? And knowing the customer is the key element. Okay, once you know your customer, once you know the customer base, then you can think of either the product improvement or security part of it, basically protecting your business from any kind of litigation and staying ahead of the competition with respect to other who are in the same space. Okay, so these are nothing but some of the big data benefits that we spoke about before. Now, I'm going to skip over. I want to make it a little bit interactive. So try to answer this question like, how has data changed over time in your life that you have seen? And how has that affected in the current time? And what can we do with it, right? Because data is getting changed. Data itself is not getting changed, but across the time span and with different geographies, you have seen how the data gets affected to an individual, right? And are we going to mask the data? Are we going to make sure that data is being democratized and everybody is getting access to it? How are we going to manage that? Okay. Answer in the chat if you have access to the chat. See, give me your couple of sentences around how data has changed over time, right? What do you see like data getting changed, and what impact would it have, and how it has affected you personally, right? Is somebody monitoring the chat?
Yes, sir. Yes, sir.
Okay, all right. Hope some of them would answer it. Okay, let me move on. So what are different sources of data, right? Who does generate the data? It's been human generated. Like we said before, if you carry your cell phone, if you're going to look at the news, anyway, that you're going, that human is the main source of data generation. Some data gets generated by machines. You might ask how. Right now, most of the products that we use are electronically or chip induced, right? Whether you look at TV or even when you drive a car or even your refrigerator is all generating the data, right? Even if you're using Roomba for cleaning the floor, and that also generates the data, right? Those would be categorized as IoT, Internet of Things, and data gets generated from the machines, right? It's not just the laptops or the phones that generate, but every machine which has an electronic chip embedded into that would generate the data. And in the last topic, we know that organizations do generate large amount of data to run their business. Okay, this is the key driver for their keeping their business afloat. So these are the three main sources of data that gets generated. Now we'll come to how are we going to collect this data, and how do we store them? What are the different ways that we are going to retrieve some of these data that we are being generated across the different sources? Okay, it's not necessarily that humans or machines or organizations just generate the data in an structured manner, right? If you share your photos, if you share something that's been running in a streaming mode, not necessarily those have been in an structured or organized way. So they are all unstructured data, right? We'll come to different data elements and different objects that are being tagged to any data that gets generated. So you might have heard about this many times before. What defines the big data? It's basically nothing but a volume, velocity, and variety. I don't have to talk much about volume of the data, which been terabytes like per second or per minute. A lot of people are looking at the volume of data, right? A lot of subscribers, even government would get the data in their own way, and all the big companies are generating the data, and they are collecting data. Even Twitter, if you take for example, Twitter is also collecting a lot of data whenever somebody tweets and retweet, right? And velocity, and this is the rate in which data gets consumed or data gets generated, right? Velocity. And earlier the velocity was a lot less. Think about it, about 40-50 years back, there was a print media, and they would generate it's a one way. They would give you a newspaper in an paper format, and people would consume it. There was not much of velocity that they would get the data in. But nowadays, the velocity of retrieving the data has increased tremendously. And the variety, like we spoke about before, there is a lot of different ways that you can get the data out, right? It may not be an structured element alone. It could be any way that we are generating the data, right? It could be as simple as a document. It could be photos, images, various things, right? Now, variety of data, you have seen like many ways, and you know each of these icons, what they stand for. Like this is a postal mail, and you know the DNA, and the medical data that you have, and retail information you have, and information which are collected by doctors, like a lot of different ways. And research R&D is going to generate a lot of different varieties of data. Each data would not be in the same format, right? You need to cater to different formats of data that's getting generated. And volume of data, we know that this is where we were like a few years ago, but now you can see that volume of data has increased tremendously. And the velocity in which we are generating the data, like earlier it might be like a daily feature, but now it has come down to like million microsecond. We are collecting the data. I want some of you to take a minute to answer this question. What is an example of a transactional data here? Whether creating a purchase order, an insurance claim, an audio file, a social media post, and video file. Choose any two which you consider as a transactional data. A simple question. Hopefully, we'll be able to answer them. Query to organizers. Can the participants, can they answer this?
Yeah, they can put it up in the chat box.
Okay, perfect, perfect. Okay. I'm going to leave it like another 5 seconds, then we'll move on.
We've got the answers like purchase or an insurance claim, banking transactions.
Right. Okay. Among the two that we have here, that's a right answer. A purchase order and an insurance claim. Those two are the transactional data. Making it very simple so that everybody can participate. And the next few screens will get a little bit more deep into data engineering part. Now we are just categorizing what is the nature of data that we have and how do we bucket them out. Okay, that's the objective of this slide up until now. Okay, we'll move on to. So as we spoke before, what are different data types? So there is a structured data. You know the format. When you talk about purchase order, you know there are few elements which would run as rows and columns. And you know the data type also. You know whether it's an integer data type like a number or data type, or it's a string or a character data set, right? And whether it's a date or different data sets that you have got, those are the structured data. And semi-structured would involve a data element which could be an structured component like here, but there could also be an unstructured component where you might have an invoice copy, or if you want to claim your expenses for your company, you might tag an restaurant bill or the Uber or Ola receipts, right? Those would be as semi-structured data because you have an images along with the data. So this is semi-structured data. So what is an unstructured data? This could be an audio file, this could be a video file, and you have many unstructured data. This could be an X-ray, or this could be an MRI scan, right? And this could be an strain of virus that has been around. And those are all the unstructured data that we need to collect. Okay, giving it like a high level category of what a structured, semi-structured, and unstructured data is. All right. So this is one such example to give you all what a structured data is, right? And going into structured data should always have a schema, right? It does follow a certain rules of a schema, and I cannot change a number into a date or so. I cannot until unless I do a typecast, I cannot make a change to the data in the runtime, right? But after retrieving, I can make a change. But before retrieving, it has to reside in a particular and a restricted format. And that is a structured data. So we did talk about unstructured data. This is just an example of unstructured data. And right now, when you are chatting, this gets into an unstructured mode. Okay, but there is no format in which you have to confine to. You can just type whatever you have. And although you're typing a text, you can also have an emojis, you can have images, right? Those would all be an unstructured data. Okay. And semi-structured data, there is a component here called as an key value pair. There's a component called as key value pair. When you talk about key value pair, you know what the label or what the data implies of, and there is a value also, right? Here you can see there is a first name, and first name is Narcia, and there is a date of birth, right? Birth date, and this particular data element would follow a structured data, but for every row, if I go back here, for every row, it had a similar structure, right? I might have data, I may not have any value to it, but it has to follow the same structure. But here you can see that I might have a middle name, I can have salary, but here I can skip it. I may not have any of those values, but this particular data I can understand by looking at the key value pair. I know what the label is, I know what the value for that particular label is. Okay. Let me know if I'm going too fast. Can somebody give a thumbs up or thumbs down? So far, so good?
No, sir, it's fine, sir.
No, in the sense, okay. All right, okay. This is a little bit technical here when we talk about structure, because these three formats are going to be the basis for my next few slides, but I want to make sure that all of you have followed what a structured, unstructured, and then semi-structured data elements are. All right. Okay. Moving on, I want you all to take a moment to read this question and answer it. Just give me 1 second. Good to see that a lot more participants on this question. Looks like you understood what the unstructured data are, right? Can somebody validate the answer? What is the common answer that has been shared? Anyone monitoring the chat?
Yes, sir. It's 4, sir. 4 and 1.
Okay. Unstructured data may not be messy, but yeah, okay. Good. That was a good joke. Okay. And the one most widespread data. Yep. Yeah, that's a good insight. I think most of you have got it, because in the world, most of the data is unstructured, right? Structured data is very limited component, and unstructured data comprise, if we talk about the volume of data that we receive, probably this would be more than 90% of the data in the world is unstructured data, right? Good. All right, we'll move on to the next slide here. Yeah, participate in the chat so that it makes it interesting for you to get it. Okay, so how do we make sense of the data? We were talking about there's a lot of noise, right? When you get a data element, see here I have got say different colored M&Ms, right? These are all the chocolate tidbits, right? M&M chocolates that you might have seen. If I pour that everything into a bowl or into a beaker, and if I want you to categorize and find out the color M&M, and if I want you to sort, that would take really a lot of time for an individual to do it. But it could be done, right? It's not like an ask which is impossible. Yeah, somebody raising their hand. Okay. So this is how we can get the data element. You can get the final count, but if you have to distribute, okay. So we'll come to distribution. This is part of the data engineering. I'm just giving you an overview about how do we collect the data and how do we interpret the data, right? If I have to sort, how am I going to do it? And sorting is the biggest challenge when we talk about big data element, okay? And there are two different ways that we can collect the data. One is in batch processing and one is a streaming. So what is batch processing? Batch processing would happen at an given interval, right? In a given day, it can happen at say like 8 o'clock in the morning if I'm going to run a batch job because I want to know prior day whatever the transactions happened. I want to collect all of them and then put the report out in front of the management. Then I'm going to run the batch and keep the data ready so that it gets accumulated, right? So here is the one example where most of you would have been using cell phone, and you know how you get billed. So how do they calculate that? So there is a batch job which runs on daily night or daily once or twice a day, and they do figure out for each customer and for each number where all they called. And this data is like one for to generate the bill, and the same data would also be shared with the local authorities if there is any data that they need to check for what's going on around them. Okay. So you have the cellular data. It would contain various data elements. It is not just the number that you called and the time of the call, but it also comprises of many data packets that they would collect. Okay, so every cell tower does send many data components. It is not just the one where you are going to raise the voice and you are going to the other person is going to listen and then return back the call. Okay, it could be text or it could be any kind of an communication that you are making, or you can sending the images. Those are the cellular phone data, but the cell tower does send more than the data that you have actually transmitted and received. Okay, and that could be used at a later point in time, but I'm not sure whether I have time to go into all the details, but giving you an overview of just to get a cell phone bill, how much of data gets churned behind the scene. to generate one bill for any given customer. Okay. Streaming data is the biggest challenge at this point in time. I think we have overcome that, and COVID has expedited some of the streaming data across the globe. How do we stream any given information, whether it is an educational institutions versus any meetings that had to happen or any organization? Okay, so streaming data was one of the big thing, and nowadays streaming doesn't mean just having it for official use, but also for entertainment. You can use the streaming data. Okay, but now the stream data has been mostly reviewed by the doctors to look at the health of any not just a patient but also any individual, and this data gets collected. And it's not just doctors who are looking at this data. This data goes into Apple, it goes into Google's of the world, and it goes into many cell phone subscribers that you have got, right? T-Mobile, Verizon, AT&T, and India Reliance, a lot of them are collecting this. This data becomes very important for policy decisions that have been made by a government. Okay, so this one such data alone, that anybody is carrying their fitness belt or fitness watch, does carry a lot of information about a given individual. Okay, and this can have taken influence on how the policy has been made, or intake of a salt or intake of anything that has been sold in the market in a given area. Okay, so that's a streaming data. Can we continue, or you need like a couple of minute breaks? Sort of at this point I want to share, take a break and look at the questionnaires if anyone has any questions.
Yes, sir. You wish we can have break also, so you can take the question.
So we can take up the questionnaires. I think one question is there in the chat box. If there is any increase in the consumption side effects, can it occur if big data gets hacked? So that is one question asked by one of the participants.
Can you repeat? Could you repeat that? What's the question?
If there is an increase in the consumption side effects, can it occur if big data gets hacked?
If there is an increase in consumption, what do you mean by consumption side effect? Can it occur if big data gets hacked?
I think if
Okay. I mean, that's true for any data, right? If a data gets hacked, and what does the data hacking mean? Hacking means you can snoop into the data where you are not allowed to. Like, for example, there are various ways of hacking. Okay. One is you can hack data through and web services. You can hack it through an API. You can hack it through getting in through an SQL injection. There are many ways to get or steal the data, right? Whether somebody gets access to modify, right, to update the data, that's a rare occurrence. But yes, there are chances of that happening. If an employee leaves a company and they don't shut down his or her access, yeah, definitely that person would go back and modify. And when you're talking about big data, there are like huge volumes. Right? We can go and then you can make a change to it, or you can take a copy of it and then use it for any of your personal purposes. Okay. But now the question remains, what is the validity of the data, right? Data which might be relevant as of today doesn't be relevant as of tomorrow. Data gets changed. Like if I have a stock market data as of now, it's an obsolete data. Just for an info, I can use it for tomorrow or maybe a year later, but it doesn't make much sense of what revenue impact it would have made to any of the individual. Okay, the various ways that it could be hacked. I hope I'm getting your question right. But would it have an impact on the big data? Yes, it does. And that's the security was the biggest component that we spoke about like 5 or 6 slides prior. Security is biggest component. So looking at the data, knowing your customer, who gets into the database and who gets into the data storage, right? We might have kept all the contract files. right? To give an example, all the land and how rentals or house properties that have been across any given jurisdiction, they are going to maintain that, right, in the local government databases, or they would keep a copy of it in different files. If somebody gets access to it, they can look into the data. Yes, it does have an impact on how the data is being managed from then on. I don't know if I answered your question. Did I get your question right? Who asked it?
Shrestha, I think she can put it up in the chat box whether the answer convinced her or not. And there's
Okay.
another question actually. Sir,
Mhm.
what will happen if the big data gets crashed? Can it be recovered considering its huge quantity?
Yes. Okay. I'm going to touch base on that. That is the biggest topic that we have got. The data that we are going to generate nowadays, most of the data are being kept. When I cover next slides, I'm going to talk about, but just to answer your question right now in a very high level, data is not maintained no longer in an on-premise, right? On-premise servers have certain limitations of how much of data it can store. Uh, Large organizations, they're moving into cloud, right? Mid-tier organizations, it gets very expensive to keep the data in-house because you have to pay for your administrators and for your infra team. And large organizations, if they have any confidential info that they have to maintain, they will maintain, but confidential info is not an big data element. Okay. Okay. Coming to the second part of your question, what happens if it gets destroyed, or if it something a fire happens? That is the biggest concern our large organizations have. That's the reason you can see that data gets spread across the globe. They don't keep it in any one particular location for various reasons. There could be an earthquake, there could be an say mass riots, or there could be a civil disobedience that happens in any country, and they can destroy the buildings, right? They can put a fire, or there could be an earthquake, or building itself could collapse. And these are various reasons where they do a mirror image. So how the mirror image happens, that's part of the data engineering. This is a pretty good question, but very in-depth question. So data engineering also deals with how do you make a copies of the data, right? There won't be any one single copy, there will be multiple copies. Now, going back to your other question of how do we recover it, there is something called as time series. When we talk about time series, you can go back in time, look at the data, at what point in time we lost it, and you could recover everything back. Okay. So data that we are going to receive has got multiple components. So there's a component called data lake, or data where you are going to dump any info that gets called into the area that you are monitoring or you are looking at, that you are collecting the info. But once you have the data in the data lake, subsequently we are going to make a sense of it. Those are called different layers. That could be a bronze, silver, and gold layer. I'll talk about in the rest of the slides. Any other question?
Shrestha
Okay.
has confirmed that she's understood your answer, is clear with the answer.
Okay. Thank you.
Then there are few more questions actually in the chat box. One of the participant is telling that they are not clear with, sir, the picture wise semi-structural or unstructured, that I'm not able to discriminate. So they're not able to discriminate between the semi-structured and unstructured data. So I think
okay, that's fine. I'm going to go back here. Okay. I'm going to go back to the slide. That's a good thing that you're observing. So structured, I don't think I have to repeat again. Unstructured data is like, basically, to make it very simple, think about it as an image and combined with the text, right? Make it very simple. That's an unstructured data. Whereas semi-structured data is a key value pair. When we talk about key value pair, you can see this, all the elements. You can see there is a flower basis in the beginning and there's a flower basis in the end. Okay. This entire data is part of one data set. Okay. You might have in your algebra, you might have heard about data sets, right? Sets, and within the data set, you will have a kind of a matrix. If you are going to build, you can talk about within a data set, you are going to have a key value pair where there is a label or there is an element which is going to describe what this data is talking about and what is the value associated with that, right? Here you have an birth date and you have gender and also you have a social security number. When you have a social security number, it always comprises of this format, right? And this is the value for the social security number. Social security number is the column header, or you can call it as a column label, or this is going to define what is the nature of data that I'm going to get the value for. And this is the value for that particular data label or data column or that particular data type. That's the semi-structured data. Semi-structured data need not be like, if I'm going to go down here, I may not have a social security. I may not have any of this data at all. I can actually add a couple more things. I can also add an address to this, right? Here you can see only for name, date of birth, gender, ID, and then social security number. I can also add an address to it. But that's not going to distort my entire data that I'm reading. Okay. So semi-structured data would be a schema that you are going to define. And if it doesn't comprise within that schema, it's not going to make a big deal about it. Whereas in a structured data, I cannot go and add an address to this, right? There is no way that I could add any address to this particular data set that I have got. So there is a rows and columns which are well defined. And even within the column, I do have each of these values that are defined with a structure, meaning this could only be a number. This I cannot enter a character in here. So those are all well defined when I come into the structured data. But similarly, when it gets into the semi-structured data, I can have a last name here, but I can also have an image here. It doesn't matter. Is that making sense to you? Whoever asked this question?
I'm just waiting for their confirmation. Meanwhile, one of the participants is telling that social media is unstructured data, and structured data can be zip or RAR file. So maybe they're asking in what type of file can the structured data be, and what type of data is social media.
Okay. Take for example, you have an, I think most of you might be familiar with what does Microsoft Excel would do, right? I have a column and I do have a row. I'm going to put the data in there. I'm going to compress the data. When I compress it, it could be a RAR file or it could be a raw file, or it can make it into a zip file, okay? But still, when I'm going to export or when I'm going to expand that compressed file, I'm going to get a structured data, right? Because in the Excel, I have defined rows and columns, and I do have the data which is comprising within each column what the rows that I have entered the data in, right? That could be a semi-structured data, but is it an image data? No. But when I'm going to place an raw or the zip file onto a document, right? In a document, you have to attach, let us, for example, you have to say you're filling up an application form. They ask you to share your prior, whatever it is, transaction that you have made for your claim, right? Insurance claim, you have to share like when did you buy the car, when did you buy your vehicle, and then where did you buy it, and what is the damage. All that element that you have got, you're going to attach it. When you're going to attach it, this whole document itself would become an unstructured data. Okay, it's a document. Basically, you have to read the document each and every, I have to use an OCR, different techniques or different methods in order to reach each and every line in the document to make a sense out of it. Okay, that becomes an unstructured data. Did that make sense to you?
So the same person is asking, chat box will be behavioral data. Is it structured data? He's asking. The person Rishabh.
Okay. Okay. Chatbot is an chatbot is an AI driven component, right? You have a preset list of questionnaires and you are going to have an answer looking at it and you are going to reply back. That is a chatbot. Chatbot doesn't do more than that. But chatbot could also add the AI component and then make chatbot itself can reply back to any human when they're asking any questions. Chatbot data, where it is retrieving from, that is an unstructured data. Okay, there is no structure to it because you can ask any question, like you can, like for example, you're going into Google Map or into any one of those. It will look at all the images, then it's going to scan through using the GIS component and it will provide you the info or the answers to your questions. Okay, that is an unstructured data. But when you're asking about Q&A, like FAQs, I have got like an Jain University website. I'm going to have like preset list of questionnaires. You're going to ask anything based on the questionnaire that you have asked. If it's going to fall within the Soundex or a similar kind of questions with the keywords, I'm going to reply back. That's a chatbot that I've got. Okay, that chatbot that I've got is an unstructured data. Is that making sense to you?
Yes, the participant is confirmed. Thank you, sir. And what is one last question probably? Participant is asking whether he can use Apache Kafka for batch processing.
Kafka, Apache Kafka. I'll come to that in slides in a few slides down. Yeah, Apache Kafka is one of the streaming element. We'll come to that. Right?
Yes, sir. I hope that's the end of the question.
Okay. Okay. Now, a lot of people nowadays would have heard about these three elements, right? And they are the drivers for most of the people that are dealing with the data at any given time, right? They will talk about artificial intelligence. How would I make a sense out of the data that I have received, but also look into the data more deeper into the areas where humanly it would have not been possible. Think about it. For example, I'm going to provide about 1 million X-rays, right? Humanly, it is not possible to scan through it to figure out what is the nature of the malign or any kind of limbs that are available in all of these million plus X-ray scanned images, right? But using artificial intelligence, I can make it happen and also look at the similarities that may not be visible to human eye when I'm going to look at the scanned images of the X-rays, right? And that's an artificial intelligence component. And I can also add in the future, this also has a capability of learning, right? It can also predict, okay, you gave me these million images, I'm going to use this as a baseline. But in future, if you're going to give me any more images added to it, then I look into it and then say, okay, this particular image, what you gave me, has a potential of getting a limb in 6 months from now or 8 months from now, because this particular artificial intelligence has determined how to look into the data even in the futuristic mode, right? Machine learning is again a subset of an artificial intelligence. Those two are a little bit different, but machine learning would also look at vast amount of data, and it has a capability of learning on its own, right? And quick example for this is using machine learning. There are programs which have been written nowadays to look at how do I drive in a congested road, right? So my vehicle itself as a mission, I can make it to learn. We're navigating it through many times on different congested roads, and it does know where to stop, where to look at, and what action to perform next. Okay, but this also has an AI component, but there is also a machine learning component to it, looking at the vast amount of data that it has received. right? And similarly, and this is one more subject that has been very popular, deep learning, right? Deep learning is nothing but a subset of these two areas. I mean, I cannot call it as a subset, or three different disciplines, three different study on its own, but all three are interrelated in a way that you can talk about when it comes to some of the algorithms, some of the models that you use. Each could be extrapolated with each other, they could share, okay? But why am I talking about artificial intelligence, machine learning, and deep learning on data engineering? Without data engineering, all these three are impossible. Okay, data engineering is the baseline. Data engineering is the foundation to have data made available, which is curated to reach into any of these data science elements. Okay, data science elements are depending on the data that has been received, but as I spoke earlier, there is a lot of noise in unstructured or even in a structured or semi-structured data. I can receive multiple volumes of data, which doesn't make sense. There could be a lot of duplication. There could also be an damaged or an image which doesn't even make sense, right? So artificial intelligence, if I generate a lot of this data, it cannot discriminate between or distinguish between a cat and a dog. It makes a lot of, that particular decision would have a huge impact. I mean, it can be funny when you talk about cat has been identified as a dog, but think about it when an MRI image gets wrongly diagnosed. That would have an impact on human life, right? Similarly, nowadays AI has been used vastly to pick the stocks, right? Nowadays, you don't see a stockbroker who are actively monitoring, looking at the trends that are being fed either from a Sensex, Dow Jones, hence I like all the indexes around the world, and even the currency market around the world when they are looking at how the fluctuation, if there is any dip or rise. Artificial intelligence nowadays are causing an havoc, but at the same token, they are also making a lot of people millionaires, right? Looking at how the advisory board that they have constructed out of AI, and some of the bets that they make on an ETF or some of the stocks that your stock picking nowadays has been translated into AI. Human element or has been has been I cannot say eliminated, but human element of picking the stock has reduced considerably in past few years. Okay, a robo stock picking has become a trend of the day for any brokerage firms. So all of that would need massive amount of data to be kept alive and in an optimal way that it could be accessed and it could interpret the data. Okay, all the three components that we have put up here would need data engineering, and that is the preset of getting into the data engineering component. So AI, we just spoke about it. Basically, it can imitate an human intelligence, but at the same token, it's in a very primitive state at this point in time. A lot of investment was made in 2018 and 2019, but nowadays you can see that except for few areas like for banking and some areas and security firms, not much of AI has been improved, but eventually this is going to scale up, and all the organizations, whether they are into manufacturing or whether they are into data collection itself, or they are working with external clients, all of them want to use this artificial intelligence at some point in time to eliminate the human repetitive work that has been done, right? Basic element here is labor arbitrage, it's called. The component labor arbitrage is nowadays, even whether you want to have an person working, depending on any region, it gets expensive, right? When you have an AI bot that would eliminate keeping a person working on, that's one of the key component of or the motivate for any organization to have AI. And machine learning, we spoke about that before. And machine learning for gaming purpose, right? When you are playing any games on a computer or on video games, or when you are going to use it for as simple as, say, you want a particular task to be routinely done. And nowadays you might have seen some of the uh, restaurants, right? Especially McDonald's, White House kind of restaurants. What they do is they have a preset way of preparing a burgers or preparing a particular dish, right? It's not a dish basically, it's a fast food. And they have made the entire process to be picked up by a robot, and it does learn to flip the burger, to take it and put it into oven, and into at a certain degree it knows how to take it out and put it onto a plate and then serve it to the end customer, right? The whole area has been done through machine learning. And if something breaks, it knows how to move away from a particular oven into the next oven, or to uh, open and microwave and then put it into microwave if the oven gets broken. All that has been thought through. And machine learning nowadays you can see in some restaurants, even probably in some locations, and the servers who are coming with their plates that has been replaced, right? Those are the robots that gets introduced by the machine learning. um, and deep learning is basically a subset of the machine learning that we have got, and this goes through neural networks. And it is basically trying to emulate the human brain. But this is the dangerous subject that we are getting into. Once this area gets a lot of funding for the deep learning, it's going to override AI and ML, right? Deep learning has a lot more impact than both machine learning and AI, because this can be an human, including having an emotion attached to it. Okay. Once we get into this point in time, you can have, say, replace a human without much of an hassle. Okay. This is one area where a lot of research has been going on, and let us see how it goes in future. Uh, uh, Data science, again, the repetition of what are the different tools and techniques that you need to get into the data science. And most of you might be interested in that. But data science is a curated group, right? I'm not trying to downplay data science for AI, ML, or any of this, but to get into the job market in the current given situation, it's more into the data engineering. Data engineering takes about 80% of the work, and probably less than 15 to 20% would be for AI, ML, and DL. Okay. Uh, it's not the opinion, but that's the current trend that we are seeing. We can see the data science workflow, sharing of data insights and identifying business needs, analyzing, preparing data, and ingestion of data. All of this would be the different components that are there in the data science workflow, right? Starting from collecting or ingesting the data, this is where you start, and then you can around about go all around about how do we get the data, make and sense out of the data that you have collected, and start analyzing it, sharing the insight. And this is the component where ML and AI would come into play. And you can have a business need, whatever the business motives are, those could be identified, and those could be uh, met using the AI or ML component. Even humans can make some sense out of it. Okay. Once you have the right data set, once you have prepared it well, and this would be the end result of that, sharing the insight and identifying the business needs. And what are the business needs? Like we spoke about before, one is security, and one is identifying your customer and aligning your product. How do you sell more of your product without keeping it on stock? And third one is how to keep afloat with the competition. Those are the key drivers for any business. But it's more than that. Nowadays, businesses are trying to snoop in and then gobble up some of their competitions too. Okay. This is again repetition of what a data science team would comprise of. It starts from a data engineer, right? Data engineers and data analysts have the maximum amount of job that are available in the current world market, in the job market. Platform administrators, these are being moved away because most of the companies are not trying to keep the data in their on-premise, and platform administrators are getting into the cloud. Once you have the cloud native, or once you have the cloud exposure, whether it is AWS, Azure, or Google, GCP, Global Cloud, there are many cloud platform where at this point in time we can look at each one of them. It doesn't vary much. All of them have an endpoints. How do they connect and how do they manage the data that has been residing in them? Okay, and data scientists are the one. After all these three components are done, then you would have a data scientist who would come in, look at the data and make some sense out of the data, creating the models or creating either an AI or ML or DL part of it. Okay, that would be the last component for data scientists, and this has become a niche element, and also not many jobs are coming through at this point, but eventually in future this is going to open up a floodgate. Okay, at this point it's mostly data engineering and data analysts and platform administrators have a major chunk of the job market. And now again, Q&A. I'll take a look at this and answer it in the chat, please. One of you organizers, you can read.
Yes, sir, yes.
Yeah, go ahead. Meanwhile, I want to ask, like, how much more time do I have?
Sir, till
Sir, you
8
can
o'clock.
20 minutes?
20 minutes
Kirtana?
more? Okay. 20 minutes more. Okay, good. Okay, hopefully you would have got some answers. Can some of you read out the answer? Whatever has been.
Participants are telling machine learning mostly. And a few of them are confused. They are telling deep learning as well. And few of them are telling data science.
Yeah, data science is the right answer, right? So we did go about that in the prior slide. It is data science that would require all of them, right? For insights from the data, techniques for extracting the insight is a computer science, statistics, mathematics, and business. Okay, we'll move on. I want to have one more quick question here. This, if you have heard carefully all the prior slides up until now, you would know what the significance of it. Yeah, just pick 1, 2, 3, or 4. I don't want to rush through for the rest of the slides, but there is a couple of important slides that I want to spend some time on before we close the call.
We have a mixture of answers, sir. We are getting 4, 2. Most of them are telling 2. It's 2, but few of them are also telling 4.
Okay. We are talking about what is the ultimate goal. What is the goal, right? Once you have all the data from the world that you have received, what is the goal? The goal is to generate the dashboard, right? So that business leaders could make sense out of it, right? That's the ultimate goal. Okay. So in the beginning, we were talking about what are the different challenges. Look at it. What would be the challenge that any organization would face working with the big data? One is like to get the data assembled and kept in one location where it is easily accessible. That is a layman term, right? But that is the biggest challenge. How do we keep the data that we are receiving, the velocity and the variety of data that we are receiving? Where are we going to store it? How are we going to manage that? How do we make sense of the data that we are receiving? And that is the biggest challenge. And those challenges are primarily revolving around data engineering. Okay. And collecting data. And now onwards, I'm going to, for next 5 or 10 minutes, I'm going to talk mostly on the data engineering part of it, focusing on how are we going to get the data into the space that we have access into. Okay. Traditionally, it was data warehouse, and nowadays it is becoming a data lake and lakehouse platform. So data warehouse is where we are going to store large amount of data from the transactions from anywhere that you have received. And data lake is basically nothing but a dump of any info that you have received, right? Anything that you have received, you could dump it into a data lake. And primarily, most of them nowadays are using cloud platform to dump the data into the data lake. And why would they do that? It is a lot cheaper to dump it into a cloud. And also it is secure now. Earlier there was a question of security. Nowadays it is much secure. And also you can access the data at any point in time. Until you are going to download the data, you're not going to pay for it, right? There is an agrees and ingress charges. And only when you are going to agrees, basically you are going to collect the data from there, creating a dashboard. That is when you are going to pay for most of the cloud services. Okay. And Lakehouse platform is a combination of all combined. It could be a human database and also a cloud platform. So data warehouse, quickly run down into what would be the pros and cons. Data warehouse has been kind of a matured data. We have different schemas like Snowflake schema, Star schema, different schemas, very reliable, and it has matured itself into providing fast read and write. But this depends on how much you have invested on the hardware, right? The problem with data warehouse is it is primarily unstructured data, right? And every time that you are going to buy a data warehouse, you have a particular, either it's Oracle, SQL, or one of those big vendors that you have, or Sybase, right? You are locked in, and moving away from one vendor to other vendor is a huge exercise, and it's very expensive to manage and maintain. Data lake, again, as we spoke before, here are the pros and cons. Basically looking at the organizations, it can collect even they are not sure about whether they will need this data, yes or no, right? One such example was Roomba. Roomba is an carpet cleaning or house cleaning. It does clean the floors, but it would create an images of the house, and it would take pictures of the furnitures around. Because it has to navigate, right? By then, this particular boy, he looked at the data and it was shared. It was like billions of dollars worth of data that he was residing on. Using the data, real estate market, you could figure out with a given and customer with a particular revenue group that they are in, economic zone that they are in, you could figure out what kind of paint would they use for their walls, and what kind of furnitures would they buy. And that is the data. And here are the major contribution. Like he could make billions out of that data alone that he could share, right? And those were the pros of data. Like you even if you are not sure about whether this data is relevant to you or not, you could still collect and then dump it and keep it in the data lake. But the problem there is, like, you need to make sense of the data. That is the biggest concern of keeping every data in the data lake, right? So now I'll quickly go over what the data lake house would look like. It has got an BI component, which is basically the dashboards, and machine learning component we spoke about before. And metadata is nothing but the data about the data, and it can have an indexing, caching, and it could have any kind of an ETL. Basically, You could extract, transform, and then load. Okay, you could extract, transfer, and load the data, and it could comprise of all structured, semi-structured, and unstructured data. Any kind of data could be dumped into a data lakehouse. Data security we did talk about before. Consolidated data security policy. This is where data governance would come into picture, and we need to talk about how how to secure the data that you have received, right? And who has access to it. Determining that policies across different organizations, and that is the biggest business that has been generated by a lot of consulting firms to introduce the security policy. It is not just within an organization, but also for a government across the globe, right? They're talking about how do we have the security policies that have been implemented, right? And PII is one area. It's called personally identifiable information. Basically, once you are going to keep the data in an unsecured way, and you have, think about it, if there is a data breach happening on any of the credit rating agencies, millions of people would, their data would be shared in the black or in the dark market, right? In the dark web, you can go and then get any info that you need. And these are the big data security that is creeping up. But at the same token, nowadays, all organizations are particular about who gets access to it. Take a look at this particular query. In the long run, scaling up our existing on-premise infrastructure, we spoke about that before, will be less expensive since we'll own the machines. Do you prefer, or once you are in the job market, are you going to think about keeping the data on-premise, or you want to move it into the cloud, given the security and given all the complexities that are happening, being infrastructure being more and more expensive to buy on-premise at this point in time? Think about it. You don't have to answer it right now. We're running out of time, but think about this for your discussion group later on, some point in time. Okay. We're keeping the infrastructure. Where will it make more sense? These are all the elements of data engineering, right? Or using compatible with each other. Basically, we're talking about Apache Kafka and various ways of streaming the data pipeline. To quickly go over this area here. Is this slide visible?
Yes, sir.
Yeah, this is the important slide that I was talking about. I'm going to spend 5 minutes on this, and we can conclude after this. I'm going to skip over a few areas. Okay, so data warehouse we did talk about earlier. The various vendors are going to provide data warehousing, right? Even today, also we're talking about big data in cloud, but when it comes to the where would most of the data reside? It is still on the data warehouse. Okay, you might be surprised. Mainframe has the maximum amount of data still. Okay, most of the structured data, like any airlines that you go with, the airlines industries are still being run on a mainframe. Okay, and data warehouse is the next development on that. And although data warehouse has been for a few decades, still most of this data are being converted, and the data migration between the data warehouse, which was in on-premise into the cloud, this is the biggest business model that have been coming out. Okay, there could multiple ways the data warehouse has been used. Now all of them are getting into the data engineering area, where we are using Hadoop is one technology. And nowadays there is a new introduction to this data engineering. It's called Delta Lake. It's called Delta Lake. That's a new development, and that's been probably about 2-3 years from before it was introduced into the market. And only in 2021 and 2022, it became more prevalent in the industry. Okay, and that has an ACID transactions, and most of the people are moving it directly from data warehouse into Delta Lake. It's called Delta Lake. It's not data lake. It is Delta, DELTA, Delta Lake. Okay, and it does give you all of this ETL could be done. And if you remember earlier, we spoke about time series. How do we retrieve the data at any point in time it gets crashed? From then on, how do we make it use of it? Okay, that has been done through, and Delta Lake does provide that feature, time series feature. Okay, data engineering component, we have Apache Airflow and Apache Spark, and these are some of the different open source, right? Anything to do with Apaches and open source, you can go and download it and you can run through it. These are different tools that are being used in data engineering. Okay, and when it comes to streaming, somebody is asking about streaming. You have Kafka, you have Flink, and all of this Apache. You can go and look into their GitHub sites, and you can download it, and you can run through some of these. Okay, these two areas, data engineering and the streaming, they both are one big uh, area where it does provide, or it does help the data science and machine learning people to look into the data, right? So from data warehouse, data engineering, and streaming, all of these three swim lines that we have got here, these three are the data warehouse or the data lake, where we would maintain, or we would have the different data sets that we have received from various sources. We are going to manage and maintain them, right? And once you have the data in here, residing here, then data science and machine learning would play their role looking at the data that have been stored. Okay, streaming data could be a real-time or media data that you have got, and social media data, or it could be any movie or anything that has been streaming around, right? Uh, Now we can talk about some examples like Netflix, Hulu, Amazon's Prime, and those are the different com that we are using the streaming. Right nowadays, streaming has become more and more relevant, and I think even in India, you can talk about multiple platforms which have been using this streaming. Right, they store the data and then they relate to their customers. Similarly, all the banking information that we have got, all the stock market information that we've got, that comprise of both streaming as well as data engineering. These two are the major job gender at this point in time. You can have multiple job market opening. In each one of these tools does help you to get into there as quickly as possible, like with Google's or with Apache or any one of these. Talk about Apache Spark. Databricks is one such company which has put in a lot of effort to make this relevant for their customers. Like close to 5,000 or 6,000 customers are using it. Similarly, EMR and Hadoop, right? Hadoop is slowly fading away. That's been taken over by Delta Lake and different file like Parquet, Arrow, and Arrow, different files that are taking over the, they're getting replaced, right? There is a lot of R&D going around in the data engineering area, and people are working on how to make data very easy to access with maximum performance, and also making it very cheaper to store the data, right? Think about having an Hadoop kind of a system which would be on 4 or 5 copies of it, which was very huge to manage. Nowadays with Parquet, you can have the same amount of data in less than 1/10 of the cost and less than 1/10 of the size of the original Hadoop systems, right? A lot of R&D, a lot of investment and innovation going around in the data engineering area. And how do we store itself has changed, and how do we access them, how do we transform, and how do we keep the data in different layers, like in the bronze layer. From the data lake, it gets into bronze layer and into silver layer and into golden layer. Golden layer data is what this data science and machine learning team is going to use to look at and and make some sense out of the data that has been collected here. Okay, that's the biggest what you can say investment that any company is making right now on the data engineering component. Okay. So as you can see here, most of the jobs here are around data engineers. Even data warehouse has been with the data engineer. Data analyst are moving slowly into the data science area. So all these three components, data warehouse, data engineering, streaming, all of them is being dominated by data engineers. Okay, a lot to learn here, and at the same token, nowadays it's not so chaotic as it was in 2015 and 2016. Nowadays, all the tools have matured and companies are investing in the end consumers. They know what they need, whether they are in the streaming or whether they are in a batch mode, they know what to pick and choose. Okay. Delta like we did talk about, and this is the one area where we're talking about different data streams that you get in, and from data lake, how do you create a bronze? So if you talk about bronze, is nothing but a raw data ingestion, and silver is a filtered, clean, and curated data. But a silver would also have some of the business logic that you can plug in, and gold is the one where all the business level aggregates. For example, if you have a retail market, like say DMart or one of those stores, and you want to say like how much of sales that was made in each and every retail outlet, and those are the business level aggregates, and that value would be kept in a gold layer, which could be used for their stream analytics and also maintaining their warehouse, right? Their logistics. And some say like some product has been sold too much across the globe, and they want to come back and refill that, and that particular info that they are going to retrieve based on the gold layer. Okay, bronze and silver are nothing but, if I go back here, bronze and silver are the component where you're going to use techniques which have been shared in our prior slides to get the data from various sources, keep that in one particular location in a defined format. Basically, by the time that you get into raw ingestion, some cleaning would have already happened, and silver would have filtered, cleaned, and augmented data, right? Silver is the data where you run all your aggregates on, and gold layer is where you have your business logic and business dashboards that you create. Okay, this is the basis or the foundation of entire data engineering. Okay. But okay, yeah, this one takeaway by, I think this data has actually changed a lot now because of all the COVID impact. Now close to about 7 billion population across the globe are participating in this data, interacting with the data every day, right? And this is the driver for all major organizations to play their vital role in collecting the data, and that's where every government around the globe are formulate their own policies around how do they keep a copy of the data that would not leave their land, right? Their jurisdiction. And that's one area that every government is investing on. It is not just a private industry that are participating in this particular data management. Even governments are very keen on looking at it. And that's one area to keep an eye on moving forward, right? Let me know if there are any questions. I know last few slides I did skim through it. But
So there's one question.
Yeah, please,
what is the difference between quantum machine learning and machine learning?
Oh, okay. Yeah. If I get the question right, you're talking about quantum quantum computing versus traditional machine learning?
Yes, sir. Quantum
Yeah.
machine.
Okay, got it. So quantum area is still in its infancy, but eventually we were talking about three V's, right? Volume, variety, and then velocity. Probably the volume part of it will become more and more negligible going forward using the quantum computing. And that is where people are focusing on right now, even given all the advancement in how do we store the data and how do we cache the data, how do we keep the indexes well optimized. Still, there is a lot of slowness, meaning a major decision has to be made by let's say, State Bank of India, right? To because or even RBI, right, Reserve Bank of India, to make a decision on how whether they want to increase or keep the interest rate at some level. They have to collect a lot of data, and it takes time for them to look at the global mechanics and also the impact that it would have even within the country if they are fluctuate any interest rate policies, right? And now with the amount of data that we are looking at, it is still taking like a week's time or maybe a 2 weeks time for them to look at that. If that could be reduced into hours, and those are the areas where quantum computing would play a vital role in future. Not at this point in time. They are still depending on most of these providers to optimize their tools to churn the data out, to aggregate the data out. Any other query?
So there are a few more questions. Multi-product merchandising is a problem in data science. Why?
Yeah, it's not a problem. It's actually, you can look at it, unless there is a democratization of the data, right? And even in the data science, nowadays, all the models that have been built around, if it has been cocooned or if it's been holed up in one organization, then it becomes a monopoly, and that is the scary part. And multi-vendor or multi-organization involved in that is not considered as an bane. Instead, you have to consider that as an advantage, and a lot of people would be motivated to do the R&D on the team, right?
There's one more question, sir. For the deep learning model, best to build, can we use TensorFlow or Flask? Can data loss problem can be solved in upcoming future? Data loss problem like hard drive crashes or system failure.
Okay. When we talk about, I'm not sure why there are a lot of question about data loss. Data loss is not just by losing a data center or losing an hard disk or any one of that. Those days are like behind us, we can say. It's mostly getting into data loss in the term like you are going to miss a feed, right? Because of the network, or if you have any issue with, let's say when there is a streaming going on and all of a sudden there is a massive crash due to power outage. At that point, the consumers may not be able to receive it. But the storage itself, there is a lot of duplication happening, and people do not have to worry about a data loss from losing an hardware, because we are moving away from on-premise infrastructure into cloud infrastructure eventually, right? At this point in time, yes, there is a lot of single source of truth that we are managing. Eventually, that risk mitigation is going to happen in the world. And eventually, I mean, whoever has this question, if you're going into the consulting, if you're going into the job market, look at how do you take the data out of the on-premise, at least make a copy of it and then store it somewhere at a cheaper cloud version of it, okay? Keep a copy of it somewhere so that you don't lose it. I mean, as good as keeping your phone. Like if you lose the data on your phone, what's going to happen? There is an iCode backup, there is a Google Drive backup, there is a Microsoft OneDrive backup, multiple ways that you are going to backup, right? There is nowadays, you don't hear a lot of people saying that I lost my phone, I lost my data. Those days are behind us.
Sir, students are asking some of the examples of self-supervised, self-semi-supervised, self-unsupervised learning.
Okay, examples in the sense like you want to know where to get the info for those? Is that the question or?
Yeah, yes, so should I repeat the question once, sir?
Yeah, please go ahead.
They're asking examples of self-supervised, self-semi-supervised, self-unsupervised learning.
Okay. Supervised learning is part of machine learning and deep learning component, right? So when you have any one of these learning, there are two areas to it. One is a trained data, the data that you are going to train your model on. And second area is your actual data or test data that you are going to subscribe this particular model into. Okay. So it depends on how well you have the trained data. If you have a lot of synthetic data that you have given, looking at it saying that I only have a salary information from my organization, look at it and get trained to find out who has a median salary. That doesn't make much sense to have in supervised learning or any one of that, right? But if you want to make more sense to it and then look from given an inflation, given parameters around your neighborhood or neighborhood in sense, no, I'm not talking about where your place of reside, but around different countries, neighboring countries, what is happening, and you want to make a decision about how much of salary increase that you want to give, that is an learning that would have happened. It needs an past or historical information, and you are going to train the data. And trained data should be very, it should have an, that there is an sign of about in the statistics, looking at how do you sample, right? It depends on how well you have sampled the data. Based on the randomness of the data that you have given it your model to learn, then you can have a supervised or unsupervised learning. That is the second set to it, right? It all depends on how well you have prepared your training, or you have trained your model with, right? And supervised and unsupervised learning is where you are going to make tweaks around it and then make sure that your trained data doesn't get influenced. Like you have shown only dog pictures to it, but all of a sudden you are going to show a picture of an cow or an elephant, your data gets confused, right? And you should have varied samples for your images, so that you have trained your model to look at various images and then interpret that, right? And then that's the supervised. And even on the unsupervised learning is when you are confident that you have given enough data samples for it, then you can let it run in an unsupervised mode. Similar, when there are various tools right now, robotics, right? RPA, different robotic platforms are available, which can serve that purpose. You don't have to build your own models anymore. I mean, it doesn't make sense to invest more on building the models because models are available in the market for free. You can go to Google, you can go to Microsoft, you can go to many one of those. You can look at various models that are available there for you to learn. Any other
uploading to, yes, a few more questions are there.
Yeah, please.
Uploading to the cloud is easier for maintenance purposes, but data warehouse seems to be more secure.
Can you rephrase that question, please? Rephrase, uploading data is, what do you mean by uploading data is easy?
So I think they're asking like uploading the material to the cloud is easier for maintenance purposes, but data warehouse system seems to be more secure than the cloud system.
Okay. Let me make some sense on the data query that you have asked. The data that you are going to upload, uploading data is easy. I do not get that, but yeah, once you have the endpoint connectors you have well defined, is you can upload depending on the source of the data that you are originate from, right? Once you have uploaded data, you can manage the data either in S2 buckets or in an ADLS, depending on Azure cloud or in an Amazon cloud, right? I'm taking two as an example. Once you have the data there, what is the second part of the question that you are asking?
But data warehouse seems to be more secure. I think it is like they're asking if the data warehouse seems to be more secure than the cloud.
Secure in this sense, data warehouse is within your own data center, right? And it again depends on if your data warehouse data is being exposed outside, like if there are any you can say like your data warehouse data, you're going to publish that in Power BI, some of those analytic tools, right? And if that person is using it on their phone, if that person is using it coming through external through a website, then it is as secure as what is in the cloud, right? So data warehouse data, if you're saying that only the person within the building has to come in and access, I'm not going to make it this data being exposed outside the building or within the intranet, and they have to come through an VPN, like a virtual private network, then that would make more sense to keep the data on-premise. But similarly, on cloud too, if you have a VPN, it can exactly mimic whatever the data warehouse on-premise that you have built. Similar thing could be done on cloud. Okay, you could have a private cloud, not necessarily you are going to subscribe to public cloud. If you have a private cloud, it's as secure as keeping the data on-premise. Did that answer your question, whoever asked? Did that make any sense?
Yes, sir.
Okay.
There is one more question, sir.
Yeah,
nothing in this world is free. And also when we consider the aspect of long-term USS case and data ownership, people will realize how it will affect. But the biggest advantage is for apps or services which are born and brought up in cloud. Moving from on-prem to cloud is not a cakewalk for sure. I think they need one justification on this, sir.
Okay. So there are a lot of queries within your query. Let us break that into several components. Okay. One is you're asking about data that has been on the cloud and apps that are built on the cloud and your data migration, right? You have asked a lot of questions within that. If it comes to data migration, there are a lot of tools that are available now. Somebody is saying something?
Okay. Yeah.
No, sir. No, sir.
Can we please take all the questions offline? So you can route it through Kirtana. She is the student coordinator. So you can send it to her mail and she can actually coordinate with sir. Because
Yes,
yeah.
Yes, sir, we will do it. Sir.
Yes, madam. Please go ahead. Go ahead with your conclusion. I mean, I would like to thank sir from the senior management of Jain University. Sir, I mean, you have really enlightened many people. And you said, where does the data arise? It arises from all of us. That was something really, really good. And then you have given the path to all our students how to proceed in this particular direction. Thank you very much, sir.
Thank you. Thanks for the opportunity. Hope it was made some
madam.
sense to you.
Please go ahead with your concluding remarks and all that. Thank you. Yeah.
Shivani?
Yes, sir. Yes, ma'am. Yes, ma'am.
Okay, I'm going to stop sharing. So you can proceed with your, go ahead.
First of all, I would like to request all the participants, please kindly fill the feedback form. It is mandatory for the certificate and link is posted in the chat box. Thank you so much, sir, for your thoughts have woken us up and guide us down a different path. Thank you, sir, for your valuable information and taking time to speak today and sharing your opinion regarding the preparation for Industry 5.0 data engineering. So now I would like to call Kirtana to deliver vote of thanks. Kirtana?
Thank you, Shivani. First of all, I would like to take up this opportunity to thank our speaker, Mr. Vishwanath Kanagal, Project Director, Hexaware Technology USA, for giving us such a brainstorming session. I'm sure all the students would have gained a lot of knowledge from your interactive session. Thank you for making our pre-conference event more meaningful. Next, I would like to express our deepest gratitude to the director, Dr. Yese Hari Prasad, and his team for giving all the help constantly throughout the events. Then they say the success of the event lies with the unity in the organizing team. I would like to extend my thanks to all the organizing committee for giving their support throughout the event. Next, to all the participants for gracing your presence in this event. Thank you, one and all. Thank you, Shiva.
Yes, I would like to request all the panelists to switch on the videos for the formal photo. Again, I'm requesting all the panelists to switch on the videos for formal photo.
I'm not sure I'm a panelist or I'm a speaker. Yes, speaker.
Respected sir, faculties, and my dear participants, with this, we wrap up our evening here on behalf of Faculty of Engineering and Technology, Jain deemed to be University, Bangalore. Thank you all for finding some precious time in our busy schedules to join us here this evening. Have a great evening. Thank you.
Thank you all. Take care and have a good day ahead. Bye.
Thank you.
Thank you, sir.
Thank you, sir.
Feedback link has been shared in the chat box. I think a few of them have asked for it. It's been shared in the chat box. I think everyone can.
Yes, thank you all.